Welcome to Ask and Learn.
So in this problem, we have a T-bar extending from a rod, and at the support where it's attached to the wall, it's supported in all the directions. So we have force components in all three directions at that point, and that is we're using as our origin. There is a rope attached to one of the sides of the T and a weight attached to the other. So that rope goes from point 2 to point 4 and has a magnitude of F2, so in this direction. And then at point 2 is given by 3 meters in the X, 1 in the Y, and 0 in the Z direction. And then the weight acting on the other side of the T, which is just taking the minus sign in the Y direction here, is in the minus Z direction. And then we need point 4, where the point where the cable is attached, so we can get this unit vector. And that point is in the YZ plane, and it is minus 0.5 meters in the Y direction and 1 meter in the Z direction. And then we have moments acting at point A. And in this case, we don't have a moment about the y-axis because it's basically a hinge, and this T-bar can rotate about this axis here, which is the y-axis. So there's no moment there. And so we're left with 1, 2, 3, 4, 5, 6 unknowns. And we can get 6 equations from the force components and the moment components. And again, it's just a matter of being careful with the math. Just be careful and systematic going through the algebra and taking these cross products and being careful with all of that. And in the end, you're going to get that this force at the reaction at the wall has a magnitude or has in the x direction is 1,180 newtons. In the y direction is 589 newtons. And there's actually no force in the z direction, which is somewhat surprising. But again, the cable could be supporting all of the weight, and in fact it is because this component turns out to be 0. Now the tension in the cable is 1,370 newtons. The weight here, for reference, is given in the book, is about 400 newtons. So what you can see is that this load, because the cable is at an angle, is actually much greater than the weight of the thing that's hanging from this. And also this force is much greater because it's a lot of this force has a lot of its component in the x direction. So it needs to be offset by that. We also have some moments acting at this hinge, and they are minus 785 newton meters about the x-axis. So there's basically a moment trying to twist this T about this axis here. So trying to twist it as you'd expect, because the weight is acting in one direction, and the cable on the other side of the T is acting in the other direction. So you expect this to be need to be counteracted. And then in about the z direction, we have a moment of 589 newton meters, and that again is basically because we have the cable has a component in the y direction, and it's acting away from the z-axis, so we need a moment to overcome the moment created by that cable.